everybody, this is Mrs. Lehman. Sorry I couldn't be there today. A lot of times when I need to be out for doctor's appointments or other things in life, I will make a YouTube video and have it available for the substitute to play. That way I can explain everything and you guys can follow along in your books. So while I'm out, I would appreciate it if you guys could be really extra helpful, and please obviously be on your best behavior. I really appreciate that. All right, so today we're going to do a bell ringer together. So I hope that you have your bell ringer notebook as it stated in the back on the bell ringer board. What I'd like you to do is follow along as we go through this. While this video is playing, please make sure you're taking notes and make sure that you're following along, okay? If you get home later and you feel like you don't understand something, you can always go back and watch this, so that's good. This video can obviously be paused, so if you have a question, maybe you can ask the substitute to pause this and get some clarification. But anyway, we're going to get started here. The first question of your bell ringer says there are 36 red Legos for every, ratio alert, 48 blue Legos in the design. What is the value of the ratio? So this is a little review of what value of the ratio means. Value of the ratio means to put it in simplest form, put it in lowest terms, scale it all the way down, as low as it can go. So we have 36 for every 48, and that obviously is not in lowest terms. So to simplify a fraction, a little review from 5th grade, we are going to find some factors that we can divide both 36 and 48 by, and if you want to do it in the quickest one-step process, you need to find what we call the greatest common factor. So a number, the biggest number that will go into both of these numbers. So if you think about it, the biggest number that will go into both of these is 12. So we're going to divide by that greatest common factor. So 36 divided by 12 is 3, and 48 divided by 12 is 4. So we know for every 3 red Legos, there are 4 blue Legos. All right, so the value of the ratio is 3 to 4. Part 2, or question 2. If a recipe calls for 2 tablespoons of cinnamon to make 10 muffins, how many tablespoons of cinnamon would be needed for 50 muffins? So 2 tablespoons will make 10 muffins, and we want to make 50 muffins, all right? So what you would need to do is to show some work first of all. So I would start with writing the ratio. 2 tablespoons, that's of cinnamon, for every 10 muffins. And it's really a good habit to get labeling these things, because when we start setting up proportions, you're going to want to make sure you're very neat about how you set them up. So the other part of information we've been given is that we plan to make 50 muffins. So you want to put that across from muffins in this proportion. So 50 muffins down here. So obviously we're scaling this up. We're increasing our recipe, right? So to do that, we have to look at the connection from 10 to 5, and we're going to multiply by 5, right, to do that. So you would do the same thing to the top. 2 times 5 is 10. So I know that I'm going to need 10 tablespoons, spoons of cinnamon. So the answer, we're going to pull it out of that proportion and write 10 tablespoons. Okay, that's one method. Method numero uno. Method number 2 would be to make a ratio table. So this is cinnamon to muffins. Right, so 2 tablespoons of cinnamon will make 10 muffins. You could keep scaling it up from there. So every time we add 2 on the left, we add 10 on the right. Until you would scale it up to 50 muffins. So we know that we need 10 tablespoons of cinnamon. So those are 2 methods. Today we're going to learn a method called a double number line, where it's essentially like a ratio table. And if you pay some quick attention here, so I'm going to give you a quick example. So So let's say we have, instead of a ratio table, we start with 2 number lines. And one line needs to represent the tablespoons of cinnamon, and the other part of our ratio is the number of muffins. So it's just another visual way of scaling this up. So we have 0 tablespoons of cinnamon, you're going to have 0 muffins. But if we have 2 tablespoons of cinnamon, we are going to have 10 muffins. If we have 4 tablespoons, we are going to have 20 muffins. If we have 6 tablespoons, we're going to have 30 muffins. And then you keep going like this, keep scaling it up until you get to where you need, which is 50 muffins, okay? So you can see right here, 50 muffins require 10 tablespoons. Now, this has its benefits too, because it's kind of, usually it'll be fairly easy to see, like, okay, if we had to make 25 muffins, how many tablespoons would we need? So we need halfway between 4 and 6. We would need 5, right? So this has its advantages. Ratio tables have, you know, the advantages, ratio tables have advantages, proportions have advantages. Another thing that you might consider is finding the unit rate. How much does it take to make 1 muffin, or actually it'd be easier in this case, how many muffins could you make with 1 tablespoon, right? You can make 5 muffins for 1 tablespoon. So, you know, you can work with that too. So in Module 1, we're learning lots of different ratio relationships and unit rates and proportions and percents and all those things, and there are different approaches, okay? But the whole idea is that you're gaining a concept of how to scale these numbers up, how to simplify things into its lowest terms, and find that value, okay? So those are a few methods right there. And another method you may want to use, which you are used to from 5th grade, is maybe a tape diagram, right? So maybe I know this represents 10 muffins, and this is a tablespoon. I'm just going to call it T, tablespoon. Or maybe I should have said C for cinnamon. It doesn't matter, as long as you know what you're talking about. And then tablespoon, tablespoon. So I got to keep going with this. Now that kind of looks like a muffin. Coincidence. All right, so anyway, tablespoon, 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 tablespoon. I gotta draw one more. I'm picturing muffins. Okay, so that gives me 50 muffins, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, you have options, right? But hopefully they're all helping you understand how you can possibly approach these things. All right, moving on. Okay. So you guys didn't have this first one on this page. You had the problem set, question 31, and we skipped 32 for now, but we're going to look at Sarah and Eva's swimming rates, okay? So they gave us ratio tables to determine who the faster swimmer is. That's our job. We have to determine who is faster. So again, I'm hoping that you wrote down somewhere so-and-so, obviously using their name and not so-and-so, is the faster swimmer, because you could do all the math you need to, but if you don't answer the question, it's kind of pointless. All right, so what we worked on yesterday is we scaled the ratios down to find the unit rate. So how far could Sarah swim in 1 minute, for example, instead of 3 minutes? And when you're comparing ratios on ratio tables, you want to compare like terms, okay? So when you guys were in 5th grade, you compared fractions, and you did that when you had a common denominator. Well, we know that fractions and ratios are related, right? And you want to make sure you essentially have a common term so that you can do that comparison, because it's hard to say, oh, in 17 minutes, Sarah swam 425 meters, well, and then Sarah goes, well, in 10 minutes, I swam 260. It's like, that's not going to be something you're easily going to be able to compute in your brain. You want it, you know, easily comparable when you have 1 minute, okay? So the same amount of time. So if we scale this down, 3 to 75, one thing that you hopefully knew was that the greatest common factor there, the biggest number that would go into each of these, is 3. So 3 divided by 3 is 1, and 75 divided by 3 was 25. So we know in 1 minute, Sarah could swim 25 meters. Now Eva, she could swim 52 meters in 2 minutes. So we need to scale this down, 2 to 52. Now this can both be, or both of these I should say, can be divided by 2. So we would get 1 to 26. So let's think about what these numbers mean. In 1 minute, Sarah can go 25 meters. In that same amount of time, 1 minute, Eva can go 26 meters. So Eva's going further in the same amount of time, therefore she's faster. So we need to write that out. Eva is the faster swimmer. All right, and then explain what method you use to determine your answer. Well, we use what we are going to call the unit rate. And we will talk more about this when I'm back, but unit rate means what's the amount out of 1, right? So in this case, what's the amount of meters that these girls swam in 1 minute. Okay, we're going to skip 32 because I do what I want. I'm just kidding. Anyway, so we're going to move on now to lesson 12. So if everyone could please turn their module books to page 33, we are going to work on this question. Now, before we get into this, I know I had assigned this yesterday in class. I said, oh, do page 33. Well, then I looked at the Smartboard file and I said, oh, you know, they're going to have a hard time with this because originally it said 20 questions, which is a little more challenging than what we changed it to, which was 18 questions, okay? You should have had no problem finding that, but I was thinking it was going to be much more difficult because my Smartboard file said 20, your module books say 18, which is much easier. But that's neither here nor there. We're going to continue. All right, so we have Chantel, and she's solving 3 math problems in 4 minutes. 3 math problems, 4 minutes. I would underline that. All right, so we need to complete the table. So you can see that the number of questions is consistently jumping up by 3. Right? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Now we need to jump up by 4 minutes. So it takes her 4 minutes to do 3. So 6 is going to be double that 8. Right? We're going to keep adding 4 every time because it's consistently jumping up by 3, so we can consistently jump up by 4 minutes. So you're going to have 16, 20, 24, 28, 32, 36, and then 40. All right. The next thing says Chantel has soccer practice on Thursday evening. She has a half hour before practice to work on her math homework and to talk to her friends. She has 18 math skill work questions for homework, and she wants to complete them before talking with her friends. Way to go, Chantel. I like your responsibility. How many minutes will Chantel have left after completing her math homework to talk to her friends? Well, first of all, you have to recognize that this is going to require multiple steps. But let's go back in and underline or highlight the key info. All right, so Chantel has soccer practice on Thursday. She has a half hour before practice. Now, hopefully you know this. A half hour is 30 minutes because they're talking about how it's going to take her a certain amount of minutes to complete a certain amount of problems. So we want to make sure we're talking minutes to minutes and not half hour to minutes, okay? So we want our units to match there. The next part that we're going to highlight is that she has 18 math skill questions, and she wants to complete them before talking to her friends. And our question we're going to answer is, how many minutes will Chantel have left after completing her math homework? Okay, so first step is we need to figure out how much time is it going to take her to get those 18 questions done. So we're going to use a double number line, and I want you to follow along, do this as neatly as you can. I'm not going to bust out rulers for this, so just try to do your best here with neatness. So it's really not that complicated. A double number line is a number line that has 2 lines, okay? So therefore it's double. What you're going to do is draw 2 lines and then the starting point. So that's going to be 0 for both quantities, right? And what you're going to do next is label what each line represents. So we are talking about, in this case, questions and minutes, okay? So questions and minutes. So let's do questions on top and minutes on the bottom. Could you do it the other way? Yes, it doesn't really matter. But just like up here in the ratio table, it has these two quantities. One is questions, one's minutes. All right, so questions, we are jumping up by 3. So we're going to do 3, 6, 9, 12. I'm going to extend my lines, 15, and 18. And that's how many she needs. But we could keep going if we wanted to, but why bother? All right, so 18 is where we need to be, but we got to figure out how many minutes that is. It said for every 3 questions, it took her 4 minutes. So 4, 8, 12, 16, 20, 24, 28. We could keep going, but we can stop because we have now the first part we need to figure out how long is it going to take her to do that homework. Well, we know it's going to take her 24 minutes. All right, so that's step 1. We also have to figure out how much time she has, which is 30. So we want to find the difference of how much time she has and how long it's going to take to do these math homework questions. So 30 minus 24 leaves you with 6 minutes left. So again, we need to make sure we're answering the question, and that is how many minutes will Chantel have left after completing her math homework? Well, since it's going to take her 24 minutes, she has 6 minutes to spare. So 6 minutes is our answer. Alrighty, so again, a double number line is just simply 2 lines, 2 number lines that essentially show that ratio being scaled up. Okay, it has 2 quantities, in this case questions and minutes, and we're just scaling them up proportionally. All right, so we're going to move on now to the next one, which may be a little more challenging. Let's see. This is easy. So we're on the next one, the problem set. It says, while shopping, Kayla found a dress that she would like to purchase, but it costs $52.25 more than she has. Well, that's one nice dress, I'm guessing. Kyla charges $5.50 an hour for babysitting. She wants to figure out how many hours she must babysit to earn $52.25 to buy the dress. Use a double number line to support your answer. All right, let's go back in and underline. So I want to know more about this dress. Just kidding. It costs $52.25 more than she has. She's getting $5.50 an hour. That means $5.50 for 1 hour of babysitting. That's essentially our ratio right there, even though you don't see the number. It says $5.50 an hour, but that means $5.50 for every 1 hour, okay? And she wants to figure out how many hours she must babysit to earn $52.50 to buy the dress. So how many hours? Use a double number line. So we're going to start with our 2 lines. Okay, we're going to start with 0 on each, because if you don't babysit, you're not getting any money. All right, so we could do hours and then money. All right, so if she works 1 hour, she's going to get $5.50. If she decides to work 2 hours, she is going to get double that amount. She is going to get $11. So every time we count up by 1 hour, we are counting up by $5.50. So $11 plus $5.50 is $16.50. Another way, maybe if this helps you kind of add it mentally, $5.50 is 50 cents less than 6. So you could add 6 and subtract 50 cents, okay, because it's 50 cents less than 6 each time we do that. I'm not sure if that helps you or not, but 4 hours. Okay, so, you know, adding $5.50 here, there's a lot of carrying and stuff. So let's just think about adding another $6. So we would be up to $22.50, right? But we want to subtract that 50 cents. So it would be $22. She's got a lot of time to babysit here. All right, 5 hours. You're going to add $5.50 to 22, so it'd be $27.50. She's getting closer. All right. 6 hours. Again, we're adding $5.50. If it makes your life easier, add 6 and then subtract the 50 cents that you added on. So I'm going to do it that way. I'm going to say $27.50 plus 6 is $33.50. Subtract the 50 cents, it's $33. You can kind of see a pattern emerging here, just to point this out. You guys see how 33, 22, 11, right? Kind of cool. All right, let's keep going. 7. All right, we're going to add $5.50 again, so now we're up to $38.50. Let's do 8. I'm going to see if I can move this over. Wish me luck. Ugh. You know what I'm going to do? See, if I were here, you could watch me physically walk over to the keyboard, but since you're not, I'm going to do something real fancy here. I'm going to lock this in place. I'm going to, whoops, I don't want that. I'm going to highlight this stuff. I'm going to shift it. Hold on, take 2. So, all B. I'm going to group it all. Group. And I'm going to move it over because I'm fancy. Alright, there we go, because I need more room. You're just going to have to write smaller. Sorry, kids. But you're not writing with jumbo crayon, so you should be all set. Okay, so this is going to be $44. Man, this girl's going to need to find some people who want to go do stuff and leave their kids with a babysitter. So $44 plus $5.50, $49.50. Getting closer. Come on, Kyla. And then 10 would be $55. She's so close. What does she need? Oh, $52.25. Now, is this something that we changed in the module? Nope. Okay, just checking. All right, so we know that she's got to work somewhere on this end, the right-hand side of this double number line, right? Now, if we look at this, it's $52.50. If she only works 9 hours, she's not going to have enough money. So she needs to work how many, we're just going to go how many whole hours. How many whole hours? Well, she's going to have a few bucks left over, but she needs to work 10 hours, right? So 10 hours. A little less than that, but 9 hours is not going to give her enough money. So 10 hours. All right, we're going to move on to the next one. But again, these aren't terribly complicated. They can be, and honestly, I think they're good for simple ratios, and I think they're a good visual when you're dealing with simple ratios. When we get into some of these numbers with decimals, or we get into bigger numbers, I kind of, personal opinion here, I kind of feel like there's some more efficient methods, right? Like, personally, I would take 52.25 and divide it by 550, and that's going to tell me exactly how many hours it's going to take her, right? So, you know, we've got calculators, you can do that in like 3 seconds. So 52.25 divided by 550. But this is a good way of demonstrating it. So I'm not dismissing its purpose, and I don't want to send that message, but what I do want to say is that this is a method that you can use when you feel it's a good fit for the problem, okay? And it's an option. So math is kind of like a big menu, right? And you kind of get to pick within reason what options would work for you. All right, Anyway, Frank, question 34. He's been driving at a constant speed for 3 hours, during which time he traveled 195 miles. I want to know if he's breaking the speed limit. Frank would like to know how long it will take him to complete the remaining 455 miles, assuming he maintains the same constant speed. Help Frank determine how long the remainder of the trip will take. Include a table or diagram to support your answer. Well, I'm using a ratio table. All right, so let's draw one. Let's do 3 hours, 195 miles. So I'm going to do hours as one of my quantities and miles as the other quantity. And I know that 3 hours is 195. Well, maybe I want to scale that down. I want to find out what 1 hour would take, right? So if we have 3 hours, 195 miles, your first step I would assume that you would do is take 3 and see, does it go into 195, right? So we're going to divide here. 3 does not go into 1. It goes into 19 6 times. That gives you 18. You're going to have 1 left over. Bring down that 5. You're going to divide 15 by 3. That's going to give you 5. So that's 65 miles for every 1 hour. So 1 hour, 65 miles. 1 hour, 65 miles. We could do this whole thing where we just say 3 to 195, right? I like my way better, which is usually the case. So extend the page. So we could just keep working on this. We gotta keep getting the number to increase by 65 miles every hour until we get up to 455 miles. Okay, so if he went, let's double this, because we're going from 3, let's say, to 6, because that's pretty close to 200, 195, right? And we know he's got to go over 400, so I'm not going to waste a lot of time doing 4, 5, whatever. So let's double our 3 amount. So 195 times 2. It's 10, carry your 1, 18, 19, carry your 1, 2, 390. So that makes sense, right? Because 195 is a little less than 200. We double that, we get an answer a little less than 400. All right, so we need to keep going. We need to get up to 455. So let's take 390. Let's add another hour to his trip. Whoops, what am I doing? Add another hour to his trip, so 7 hours, because we're up to 6 hours at the moment. He's going to add 65 miles. And look what you got, kids, 455. So we know it's going to take 7 hours to do this. Alrighty? Now again, probably what I would do is I would find the unit rate, 65 miles per hour. That's how far you can go, 65 miles in 1 hour. And then I'd take 455 and divide that by 65, and you would get 7. All right, so there are different approaches. This, again, is to help build that understanding that it's the same value ratio. We're just scaling it up. He's not changing his speed. He's going 65 miles per hour for every hour that he's on the road. And that this table or a double number line, something of that nature, visually shows it. Okay? All right, we're going to take a look at this next page, and then it's going to be pretty close to time for you to go. The exit ticket. This is going to be your homework. So lesson 12, exit ticket. Please write that down in your planners right now. Page 35, okay? So again, page 35 in your planners. Okay, this question says, Kyra is participating in a fundraiser walkathon. She walks 2 miles in 30 minutes. Looks like a ratio to me. If she continues to walk at the same rate, determine how many minutes will it take her to walk 7 miles. All right, use a double number line diagram to support your answer. So again, you're going to set this up. You're going to have 2 number lines, 1 for each quantity. All right, and you're going to keep scaling it up until she gets to 7 miles. If, you know, you're counting by 2 miles and you don't land on 7, you're going to have to consider how many minutes is it taking her to maybe do 1 mile. Hint, hint. Anyway, so make sure you then write your answer at the bottom and make sure it says it will take her blank minutes to walk 7 miles, okay? So again, make sure you pull that answer out of there. All right, guys, I'm going to let you spend the rest of the class period on finishing this up. I hope you have a wonderful and safe weekend. Thank you for all of your help, and that's great. Thank you. Bye.